Okay, hi everybody. Today we're going to do combining our variables on both sides. Variables on both sides. So there's lots of ways that you can do this. So there isn't one way, but one of the things we want to do is probably combine like terms first before you start choosing sides and then undoing terms. So that just makes it a little bit easier. And then don't forget, we also have some potential special cases. And remember, if the variable happens to drop out and you get a false sentence, remember that is no solution. If the variable drops out and you get a true sentence, remember that means all real numbers. And those cases sometimes happen, so we need to be aware of them. So let's look at problem number 1. In problem number 1, and so you might find, so some kids like to maybe highlight down the middle where the equal sign is. If you don't have a highlighter, some kids like to maybe draw a little line down there so they can see the left-hand side from the right-hand side. If that helps you see that what's on the left side of the equation and on what's on the right-hand side. So if you need to do that, that's fine to do that. Otherwise, if you don't need it, that's fantastic. So remember combining like terms. Here we have a term that has a variable, and here we have a plain old number. Remember, the plain old numbers are called constant terms. Those two terms are not like each other. So there are no like terms on the left-hand side. What about the right-hand side? Are there any like terms on the right-hand side? We have a variable term and a constant term. Those are not like terms. So there are no like terms in this particular problem. So we want to now choose sides. It doesn't matter which side, but just pick a side. So let's say we want the left-hand side to just have the variables in it, and we want the right-hand side to just have the constants on them. So on the left-hand side, we want there to just be variables. So doesn't that mean we have to remove the constant 12 because we want just variables to be on the left-hand side? So we're going to get rid of the positive 12 by subtracting 12, and whatever you do to one side, you want to do to the other side. Now, wouldn't it make sense to put the minus 12 on the right-hand side underneath the term that it is like? So wouldn't it be smarter to put it underneath the 3 since they're both constant terms? And then always line up your equals. It just makes things organized. And then isn't a positive 12 and a negative 12 give you 0? And doesn't that leave us just an 8x on the left-hand side? On the right-hand side, don't we still have the x? But now we have a negative 3 and a negative 12. So what is a negative 3 plus a negative 12? Sorry, yeah, negative 3 and a negative 12. Wouldn't that be negative 15 or minus 15? So now don't we have just variables on this side? So now we're going to go to the right-hand side. And remember, on the right-hand side, we said we only wanted constants. So doesn't that mean we need to get rid of the variable term? Because we only want constants to be on the right-hand side. So we're like, hey, x, you need to get out of here. You don't belong on this side. We only want the constants on that side. So we're going to get rid of the x. And remember, that implies 1x. So we're going to subtract 1x to remove it. So therefore, we have to subtract 1x to the other side to keep the equation balanced. So on the left-hand side, isn't 8x take away 1x, just leave us 7x on the left-hand side? A positive 1x and a negative 1x, doesn't that give us 0 x's and just a negative 15 on the right-hand side? Do you see how we met our goal? Our goal was to end up with just the variables on the left-hand side and just the constants on the right-hand side. So by removing the terms that don't belong, we were able to get just the x's on one side and just the plain old numbers. Those are called constant terms on the other side. So now we can finish the problem by undoing multiplication by dividing. And we're going to divide both sides by 7. Right? 7 divided by 7 is 1x, and 1 times x is just x. And then a negative divided by a positive. So watch those sign rules. A negative divided by a positive, wouldn't that mean our answer is going to be a negative? And 7 doesn't go into 15 evenly. So we're just going to leave our answer as 15/7. So our answer turns out to be a fractional answer. Now let's go to number 2. Looking at number 2, if it helps you to put a line down there, remember step 1 is to combine like terms. Do you see that these two terms both have x's? So can't we combine these like terms? And remember, when you're combining like terms, you don't show any work. You just do it. So if you have negative 1x plus 3x, doesn't that give you just 2 x's on the side? Notice you don't show any work. When you're combining like terms, you just combine them. And then on the right-hand side, isn't the negative 8 and the negative 4, aren't those considered like terms? So don't we want to combine those? It doesn't matter which you put first. You can say that you have a 6x on this side, and then 8 negatives and 4 negatives would give you a negative 12. It doesn't, or if you want, you can say that I've got a negative 12, and I have a 6x. It doesn't matter whether you write the x term first or the constant term first. It doesn't matter. So after you've combined like terms, then you basically want to pick sides. I'm going to let this side be my variable side, and I'm going to let this side be my constant side. So notice on this side, I already have just variables, so we're good here. On the right-hand side, I just want constant. So that guy's a constant, he's good, but this guy doesn't belong, right? The 6x is a variable term, so he doesn't belong, so I need to remove the 6x. So how am I going to remove the 6x? Because he doesn't belong on the constant side. Well, I'm just going to subtract 6x. Now be careful. It's not appropriate to say subtract 6. Remember, we're taking away the x's, so make sure that you're not leaving out the variable. Line up your equals, and then what do you now have on the left-hand side? A 2x and a negative 6x. Doesn't that give us a negative 4x on the left-hand side? And a positive 6x and a negative 6x, isn't that 0 x's? So don't I have just a negative 12 on the right-hand side? Do you see how we met our goal? And how I now just have the variables on the left-hand side, and I just have the constant terms on the right-hand side? So now we can finish up, and isn't this really just a one-step equation? Like, do you recognize that this is just a one-step equation? And so don't we want to undo multiplication by dividing by a negative 4? And then be careful, a negative divided by a negative is a positive, so that negative 12 divided by negative 4 is a positive 3. And remember, we usually don't write a sign when it's a positive. Now, how do we check our answer? Because we might make a mistake. Sometimes we make a sign error, or a combining like term error, or an integer error, or a recopying error. Sometimes our answer is incorrect. How could you check your answer to make sure that you did it correctly? Well, that's what I want to show you next. When you're doing your check, so let's check x equals 3. You go back to the original equation and copy down the original problem before we did anything to it. It's kind of long. And this is how we do the check. Remember, we're going to substitute wherever we see an x, we're going to put a 3 in all of those x's, right? We're substituting. We're not solving anymore. We're substituting. So if I substitute wherever I see an x and I put a 3, remember, I just can't put 33. Remember, that means 3 times x, so I have to use 3, and I like to put a question mark, and then negative 8 plus, I just can't write 63 because remember that means 6 times x, so I have to say 6 times 3 minus 4. So notice I just recopied the problem, and wherever I saw an x, I substituted 3, wherever I saw an x. Now we're going to take each side and do order of operations on each side. And we want to see if we get the same number. We're not solving anymore, we're checking. So we actually want to do PEMDAS on both sides, which is order of operations. So doesn't order of operations say you should multiply first? And then you should add. So on the left-hand side, don't we get 6 on the left-hand side? And on the right-hand side, doesn't PEMDAS say we should multiply first? And then shouldn't we add because it came before the subtraction? Not that we always add first, but it came before the subtraction. Remember, it's left to right, left to right. And that gave us a positive 10 minus 4, and 10 subtract 4 is 6. Do you see how we have the same answer on both sides? So it is equal, so that means we actually did it correctly. So we're right, check. That means our answer is correct. And so x equals 3 is the solution. Yay, it's correct. So that is the correct solution. Now, if you got something like negative 6 equals 6, then you would say, that is not correct, and then you'd have to go find an error. You'd have to go back to your problem and go see if you can find a mistake, right? It has to be the same thing on both sides, and in this particular problem, we did get 6 on both sides, so that means we did get the right answer. We did not make a mistake. Now let's do number 3. So remember, the first thing is if it helps you to draw a line through here, that's fine. You don't have to. And the first thing is to combine like terms. On the left-hand side, I have a constant and a variable. Those are not like each other. So there are no like terms on the left-hand side. What about the right-hand side? Are there any terms that are like each other? Yes. Aren't these two terms both just plain old numbers, right? Isn't this a negative 3 and a negative 4? Sorry, trying to erase. So we've got, on this side, there aren't any like terms, so we're going to recopy. Don't forget your equals. And then negative 3 and negative 4 are both constant terms. So these are like each other. They are considered like terms. So we can combine them. So what is a negative 3 plus a negative 4? Doesn't that make negative 7 when I combine these terms? Remember, I say Nike, just do it. There's no work. You do not need to show any work when you're combining like terms. Now we're going to pick sides. And I guess I'll let my variables be on this side and my constants be on this side. By the way, there's a lot of ways to start these. There's lots of different ways you can do these problems. You can put the variables on the right side, and you can remove things at different times. So let's see. So if I'm looking at the left-hand side of the equal sign, I want just the variables to be on this side. So don't I have to kick out the constant and say, hey, you don't belong on the left-hand side because I only want variables to be on this side. So we're going to add 12 to both sides, because since I have a negative 12, I'm going to add 12, and whatever I do to one side, I have to do the other. Notice how I lined it up, the term that it's like, and doesn't that give me no, right? Isn't that 0? So doesn't that leave me just a 5x on this side? And I'm going to move this down a little bit because it seems a little squishy. So I'm going to move that, rewrite 5x here, leave a little bit of extra space. Isn't negative 7 plus 12 5? And then don't I also have the 5x? So do you see now I have just variables on this side? So now don't I want to go to the right-hand side and look over here at the right-hand side? And remember, this side I wanted to have just the constants. So don't I have to kick out the 5x by subtracting 5x? Don't forget, if you're removing the x's, don't forget to say you're removing the x's. And then what do we have on both sides? Don't I have no terms on this side? I have no constants. I have no variables. I have nothing on this side. You have to say that you have nothing on that side. And isn't a 5x and a negative 5x 0x? And don't I have just a 5 on this side? And then what happened? What do you notice? Right? Isn't this a special case? Do you see that you have a special case? And didn't the variable drop out?
Aaron Williamson.
So didn't the variable drop out? And 0 does not equal 5. So if you go up to the directions up at the top, if the variable drops out and you get a false sentence, doesn't that mean there's no solution? So you can either write the word no solution or you can use the symbol for no solution. So there isn't any answer that's going to make x to where both sides would equal the same. Okay, let's look at number 4. So maybe what you could do is you guys could pause the tape and try number 4 and 5 yourself and see how you do. So why don't you pause the tape, try number 4, and don't forget to combine like terms first, and then pick your sides, look at the directions, and come back and see how you did. Okay, so hopefully you pause the tape, so I would maybe first remind myself, and then combining like terms. Did you notice that these two terms are on the same side? They're both on the right-hand side, and they're like each other, so can't I combine these because these are like terms? They're both plain old numbers. So on the left-hand side, I have just a negative 12x. Don't forget your equals. And then what is a negative 17 and a positive 2? Doesn't that give me a negative 15 when I combine those like terms? And don't I still have a minus 4x on the right-hand side? Right? So always combine like terms first. It's smarter to do that. And then I'm going to pick my variables on the left-hand side, constants on this side. And don't I already have all of the variables on this side? So I'm good there. So don't I want to go to the right side and look and see what's going on over here on the right-hand side? And didn't we say we just want constants? So this guy is a constant term, so he's good. This is a variable term. We need to remove him because we only want constants on the right-hand side. So we need to remove the x's. So how are we going to remove a negative 4x? Correct, by adding a positive 4x. And whatever we do to one side, we have to do the same math to the other side. And then what do we have on each side? On the left-hand side, what is a negative 12 plus 4? Isn't that a negative 8x's? Don't forget that they're x's, because didn't you have more negatives than positives? And then on the right-hand side, a negative 4x and a positive 4x is 0 x's, but we still have a negative 15. So do you see how we met our goal and got all the variables on the left-hand side and all the constants on the right-hand side? And so isn't this now just a one-step equation? And since we're multiplying by negative 8, don't I undo multiplication by division? And that's how we want you to show the division bar. And that gives us x equals. And then what is a negative divided by a negative? Correct, positive. So 15/8, because 8 doesn't go into 15 evenly. And that cannot be reduced. So we're good. If you wanted to write your answer as a mixed number, you can say 8 goes into 15 one time with 7 left over. This is the answer as an improper answer, and I think most of us are okay with you writing it as an improper. This is the answer as a mixed number, and they're both good answers. I'm okay with you leaving it as an improper for now. Why don't you give number 5 a try? Pause the tape, copy number 5, and get as far as you feel comfortable, and then roll the tape, the video, and see what you did. Now keep in mind that we could have done it slightly different. There's multiple ways of doing these problems. There isn't just one way, but you definitely want to combine like terms first. So look at each side of the equation and see if there are any terms that are like each other that could be combined. So did you notice that these two terms are on the same side and they both have x's? So aren't these like terms? So can't we combine them? So a negative 1x and a negative 8x, doesn't that give me negative 9x's and a 7 on the left-hand side? Did you notice that we have an 8 and a negative 6? Aren't those like terms because they're both plain old numbers? We call those constant terms. So they are like terms. So a positive 8 take away 6, wouldn't that just be a 2 and then a 2x? Again, if you wanted to write the 2x first and say you got 2 x's on the side and then put the constants after that, that is perfectly fine as well. I like to usually write the x's first and then the constants last, but it doesn't matter. So after you've combined like terms, choose your side. So we're going to put the variables on the left-hand side. Do you always have to have the variables on the left? No. Nope. So if this side is going to be the variable side, who needs to be removed? Yeah, the 7 needs to be removed. So don't we have to subtract 7 from both sides? And doesn't that give me 0 and leave me just the variables? On the right-hand side, don't we still have the 2x? But now, don't we have a negative 5, because isn't a positive 2 and a negative 7, doesn't that equal a negative 5 or a minus 5? So now that we have all the variables already by themselves on the left-hand side, don't we need to look over here at the right-hand side and see who needs to be removed? Who doesn't belong? This is supposed to be the side that's just going to have the constant term. And there's our constant, and this is our variable. So the variable term does not belong. He has to be removed. Trying to erase. So we want to remove the 2x by subtracting 2x. And whatever you do to one side, don't forget to do to the other side. Don't forget your equals. Don't we have a negative 11x's on the left-hand side? Positive 2x and negative 2x. There's no more x's, but we still have a negative 5. And do you see that we met our goal? Do you see that we have all the variables on one side of the equal sign and just the plain old numbers or the constant terms on the right-hand side? So now don't we just need to undo multiplying by negative 11 by dividing by negative 11? And what is a negative divided by a negative? Positive, correct. And 11 doesn't go into 5 evenly, so our answer is just 5/11. There you go. Have a good day.